we're going to talk about the dot product. The dot product is an operation on two vectors, and it gives us a scalar. So sometimes we call it the scalar product or the inner product. This is how we define it. We have two vectors, u, which is u1, u2, and v, which is v1, v2. Then the dot product, which we write as u dot v, is u1, v1 plus u2, v2. So it's just a number. And if I have, if I'm in 3D space, then all I do is it's all three. So if I had u as u1, u2, u3, and v as v1, v2, and v3, then u dot v would just be u1, v1 plus u2, v2 plus u3, v3. Now, the dot product has some properties. So this theorem is the properties of the dot product. And I have three vectors, u, v, and w. And then I have c as a scalar. So the first thing I know is u dot v is the same as v dot u. And I know that u dot v plus w is the same as u dot v plus u dot w. And if I multiply the dot product by a scalar, it's the same as doing c times u and then doing a dot product with v, or u and doing the dot product with c times v. And the dot product with the zero vector is always zero because all the parts of the zero vector are zero. And then the other thing that's interesting is if I take the dot product with something to itself, it's just the magnitude of that vector squared. Think about what the magnitude is. It's just what we did here, multiplying them, but we are multiplying them, so it'll be v1, v1 plus v2, v2, which is v1 squared plus v2 squared. And remember, the magnitude is just the square root of that.